Добрый день. Сегодня мы проводим вебинар на тему Open Networking, и в частности мы сегодня вам расскажем про Open Compute Project, про открытый подход в сетях и как мы можем это применять в инфраструктуре в России, СНГ и не только. Меня зовут Виктор Ткаченко, я ведущий инженер компании NAG, в частности руковожу сетевыми решениями. И я буду представлять именно NAG как эксперт и также при необходимости буду переводить. Сегодняшний вебинар пройдет по большей части на английском языке, то есть наши спикеры, это Стив Helvie, Powen Tsai, Алекс Раян, будут преимущественно говорить на английском языке. Если у вас будут возникать какие-либо вопросы, вы можете сразу писать об этом в чат, я расскажу. Немного о спикерах. Стив Helvie – это вице-президент Open Compute Project. Он занимается развитием в целом данного направления, то есть это некоммерческая организация. Он довольно долгое время работал в Азии и сейчас занимается развитием в Европе. Основные идеи Open Compute Project Стив расскажет сам. Дальше перейдем. Powen Tsai – это представитель Edgecore, руководитель технического направления. Он может вам рассказать больше о непосредственно технологиях, которые развиваются компанией Edgecore, и в частности про Open Networking, то есть как использовать открытые технологии в сетях. Алекс Раян – это представитель компании NetResI, это разработчик программного обеспечения для управления сетью как сервисом. Они в частности нашли много выгоды именно в подходе Open Networking и расскажут, почему и как они начали работать именно в данном направлении, как они используют открытые технологии, почему это гораздо удобнее. Значит, повестка встречи, как я говорил, сначала мы начнем с проекта Open Compute Project от Стива. Далее мы поговорим о концепции Open Networking, расскажем о примерах перехода от традиционных сетевых решений к открытым и немного расскажем про опыт NetResI с некоторыми проектами. В дальнейшем можно будет задавать вопросы. Вопросы вы можете задавать на протяжении всего вебинара прямо в чат. Я буду попутно отвечать на них или просить коллег раскрыть тему подробнее. Также вы можете оставить свои вопросы в отдельном меню на конец презентации. То есть справа вы можете увидеть облачко Questions. Там оставлять ваши вопросы. Вопросы можете задавать как на русском, так и на английском языке. Если вы хотите спросить какого-то конкретного участника, спикера, например, Стива или Пауэна, вы можете прямо подписать, что этот вопрос для Стива или Пауэна. Спасибо за внимание. Я передаю слово Стиву Helvie.
Thank you, Victor, and thank you to the team at NAG and Edgecore for allowing me to present today. And thank you everyone for taking the time today to learn a little bit more about open networking. There are a couple key areas where we will be discussing the idea of open source, and many people are familiar with open source in the software world. However, in the last few years, there has been a growing effort to make the open source model apply to other industries, and open source for hardware has been taking place for quite some time, and that is the key area around open compute. It is open source in the hardware industry. There are a couple trends that we're seeing worldwide. One is there is a growing demand for data centers. We are seeing that not from just the hyperscale companies and cloud providers building more data centers, but even at the enterprise level across Europe and Asia, significant growth in the enterprise data center market. The second area where we are seeing momentum is in open source software. In the bottom right, you can see the top 20 regions outside of America that is contributing to GitHub, the main repository for open source software. And I've highlighted Russia, again, in the top 10 countries outside of America, contributing to open source. So there is a big appetite for open source across Russia. And the third area is around this growing need to enjoy cloud benefits, but in a regional or a more secure environment. There's a recent announcement around the Gaia X project in Europe, and this is an effort to build a private cloud operation or operating cloud providers across Europe to gain independence from America and China. So we see an increase in data centers, an increase in open source, and an increase for more secure data across these different regions. So with that, there are a couple of terms that I will refer to over the next few minutes, and I want to make sure that everyone in the audience who may not be familiar with these two definitions. One is an OEM and the other one is an ODM. So an OEM is an original equipment manufacturer, and they buy different components from the main manufacturers. They reassemble them, and then they sell them under their own brand name. So those are the big brand name server providers and switch providers that you see in the market. Whereas an ODM is the manufacturer itself. They provide full design capabilities, full development. The OEM is more designed for creating a product that can serve the biggest possible market. So maybe they limit some functionalities because then they can serve a broader piece of the market. Whereas an ODM can kind of specialize a little bit more based on the industry or the needs of a customer. And lastly, around support and managed services, an OEM is really geared around a managed services approach, whereas an ODM is more centered around a product. But those are the two terms that I want to highlight today. When you take the ODM, or what is called unbranded or white box market, and you add open source, you get the Open Compute Project. The way that traditionally technology comes into the pipeline is you have technology providers creating functionality. It goes to these OEMs. They decide what they want into their next release, and then it goes to the users. In the open source model, you have a group of end customers working in a community-based open source environment with end users, suppliers, vendors, working on specifications and designs, then quickly moving that out to the end users. So there's a streamlining of technology to the end user that takes place. That is the reason behind Facebook starting the Open Compute Project. This is an announcement from 2010 when Facebook announced they were going to start building their own data centers. They were outgrowing their current infrastructure and decided to work directly with the ODMs in manufacturing and designing their own hardware. So as they were thinking about the new ways of doing things, they started saying, well, what can I remove from the system? Do we need certain things in the server? Can I raise the temperature of the server? So they started to work in designing their hardware to solve these particular problems. And then they took it one step further and open sourced those designs to a community. So with the help of Microsoft and Goldman Sachs and Rackspace and Intel, they created the Open Compute Project. And just 3 weeks ago, we announced that Google has joined the board of directors for the Open Compute Project. So the Open Compute Project now is 200 plus companies. We have 6,000 engineers working across common areas of the data center hardware infrastructure. We have between 15 to 20 working projects that are led by volunteers: networking, server, storage, telco, HPC. Today, we will spend a lot of time focusing on the networking project. It is the fastest growing and the most advanced of all of our projects. There are 4 things that dictate everything that we do within Open Compute: efficiency, scale, impact, and openness. And let me give you 2 examples. This is a server bezel. It is the plastic piece of hardware that goes across the front of a server. And there are hundreds of these designs out there. And some people think that this piece of plastic on the front of a server is gratuitous differentiation, the different for the sake of being different and not really adding any value, just a place to put our brand. Here is an open compute server. As you can see, it's stripped down, it is vanity free, and I want to call your attention to these small little green touch points. An open compute server is designed where a server technician can use these green touch points to replace and repair a server without using any tools in a matter of minutes. And this is the idea behind the toolless design, the scale, and the efficiency that we drive through the common platform of open compute. Another example, in a common server, you might have 8 40mm fans in the back of that server. In an open compute server, the OU height, or the unit height, is slightly larger. We use 2 80mm fans, and there is something called the fan cube law. And that means that if I reduce the speed of the fan that I'm turning, I can actually reduce the energy needed by 7/8. So I reduce my fan speed by half. I can reduce the energy needed to spin that fan by 7/8. So you can see the efficiencies that you would get across many, many servers. How does this play out in the market? Well, this is a study done by SK Telecom in Korea, and you can see on the left, OCP servers at 0% workload versus 100% workload compared to legacy hardware. And you'll see that difference between 18 to 50% more efficient. It's not just at the server efficiency, you get operational efficiencies as well. These are studies done by Yahoo where they measure how long it takes for someone to replace and repair servers across their infrastructure, and they have been doing open compute for over 3 years. And these times may not seem like a big difference, but they are when you're dealing with hundreds of servers. So there is adoption of open compute around the world. ING Bank in Poland, RTB House, which is a media company based out of the Netherlands, Thales, the French aerospace company, is starting to evaluate open compute, and OVH, one of the largest cloud providers across Europe, is running open compute in some liquid-cooled environments. So we are seeing open compute adoption in telcos, tier 2 cloud service providers, hyperscalers, of course, manufacturing, fintech, and we're starting to see more growth in the enterprise. There are 4 reasons that people are looking at open compute, and I've touched on a few of them. One is cost reduction over time, energy efficiency. You get a great deal of standardization when you work together as a community, and you get reliability through the open source initiatives compared to proprietary hardware. So again, as I mentioned earlier, we're going to spend a lot more time on networking and the disaggregation that's taking place between the hardware and the software layer. OCP switches in this disaggregated model are growing quite rapidly. At the middle of last year, OCP switches accounted for around 50% of the switches in the data center market, in the bare metal switch market. And that is due to an interest in merchant-based silicon, the increase in SDN offerings, as well as the need to reduce data center CapEx. So what I'd like to do now is to hand it over to Powen, one of our great members within Open Compute is Edgecore Networks. Now, Edgecore Networks is not only a platinum member, but they're also an OCP solution provider. So they're not just selling OCP switches, they are leading and contributing to that open networking project. They are sitting on our technical steering committees. They are working side by side with other switch manufacturers as well as end customers to drive all of open networking. And they are the leader in OCP switch contributions and networking. So Powen, over to you. Powen?
So thank you, Steve. While we're waiting for Powen, let me have a couple words to summarize.
That would be great.
Коллеги, да, давайте небольшой итог подведем по поводу того, что рассказал Стив. То есть, насколько вы могли понять, OCP – это некоммерческая организация, основной задачей которой является продвижение открытых технологий из соображений убрать из существующего аппаратного обеспечения для дата-центров и не только все лишнее для повышения эффективности и масштабирования.
Okay?
Sorry, Powen, let me
Thank
have
you,
a few
Victor.
words. Yeah, I
Yes.
will follow up. Да, сейчас мы вернемся к Powenu, но то есть и они, OCP, налаживают максимально прямой контакт между потребителями и производителями, где возможно постоянно обмениваться мнениями, и не просто производитель решает, что это важно для рынка. Естественно, они принимают решение, хотят ли они производить это, есть ли в этом смысл, но у них есть прямой контакт с потребителями, которые участвуют в развитии сообщества и постоянно дают понять, что данное направление является правильным, а данное направление неэффективно. Поэтому за последние несколько лет очень активно развивалась данная индустрия, и на Западе уже огромное число крупных корпораций полностью перешли на открытые технологии в плане построения дата-центров, как инженерной инфраструктуры, так и информационно-технологических. Я передаю слово Powenu. Powen, please have a word.
Thank you, Victor. Thank you, Steve, for this great opening. Hello, everyone. This is Powen from Edgecore. I've been joining Edgecore Network since 2013, so already 7 years. And when I joined Edgecore, I begin as a Russia sales for the first 2 years. And at that time, it was the emerging time for open networking in data center, in cloud, just emerging. So I've been through these years and see open networking technologies and the solutions and business is really growing very fast. And all the open technology and solutions is evolving. So today, I would like to share the experience of the past 7 years, really focusing on open networking technology, solutions, and business. So as a start, let's understand what is open networking, what's the difference between open networking and traditional OEM solutions. So we understand that traditionally OEM provide both software and hardware as a turnkey solution to end user. And end user just receive the solution and product from OEM. They don't really have a good choice of others. They can only alter in different OEM vendors. Since Google and Facebook start this open networking idea concept, Facebook initiated this open compute project. The concept start to begin how we do the similar concept in server world, how we disaggregate the network operating system from the hardware. So the most important thing, the most important contribution is the ONI project here. ONI is an open network install environment that disaggregate the network operating system from the hardware. So from this ONI, we can start to see the innovation of hardware design and the innovation of the network operating system. They can start have the open and standard interface and each work and innovate in parallel. So start from this idea, the open networking concept become real, and we will see many good solutions start to happen in the market. and it become more stable and reliable, put into production environment for daily use. So after 10 years, from 2010 and then to today, 2020, we have seen Open Compute project, we have seen Telecom Infra project, we have seen ONF, Linux Foundation, and the latest, the Project Dent. Those open innovation in the open networking. So next, we understand what is open networking, but why we need open networking. Steve already gave a very clear benefits of those open compute project, which is the cost reduction and standardization and the efficiency. So let's focus right to understand what happened in the networking area. Because of the disaggregate the open hardware design and the open software as a network operating system, that's make the entire open networking become real. And the real benefits is that the end user start to have freedom of choice. They can choose the hardware supplier they prefer to work with. They can choose the network operating system ideal for their use case and deployments. They start to have a lot of choice, not only rely on traditional, only several OEM choices. So the second benefits is that they, by open architecture and standard interface, they start to have a better and greater control over their network. This is very important for a network admin. They need to understand what happened about their network infra, and between network and the computing infra, what happened. So with this open and standard, they can start to have a greater control of the network. And the work behind the scene is this community approach, DevOps approach, that drives the rapid innovation. So the real benefits of the open networking is this disaggregation and the open. And the cost reduction and the total cost of ownership reduction comes after these three major benefits. This is why we, Edgecore, as a 100% owned subsidiary of Accton Group, we see this demand in the networking industry, and we decided and committed to contribute in this open compute project networking since 2012, 2013, and we start to contribute many hardware design and concepts and ideas, and so we start to learn how to do this open networking business and share this technology and solutions with our customers to really resolve their problems and really address their deep concerns. So right now, Edgecore, as a 100% owned subsidiary of Accton, we are pretty focusing on open networking business in both cloud and emerging telco. We mainly participate in the open communities, OCP networking, OCP telco, and ONF, and TIP tip. And this is a very great overview to understand what's the relationship between ONF and OCP, OCP telco, and TIP. So Edgecore is a very key contributor in these open communities. We invested software R&D resource with ONF to develop the leading and innovative open source software components. And those open source software components are working on top of OCP hardware, OCP telco hardware, and TIP hardware. So Edgecore here, we plays a very important role to contribute in these open communities and to collaborate among these open communities. And while we contribute into OCP telco and TIP, we also work very closely with the industry trend, such as ORAN, such as multiple access edge computing, these very important innovations. So Edgecore, we contribute a lot, and we try to make significant contributions, but we don't reinvent the wheels here. So there are many good examples, so we will share later. So this is an overview about right now the Edgecore design contributions to open source communities. There are major 3 segments. The first segment is data center. So we, from 5-6 years ago, we start from 10 gig switch, leaf, and then 40 gig spine. And then we are moving to the first one to contribute the 1 gig spec, and then 400 gig, and even the next generation photonics switching. We are working on this. So this is for data center that could be used in cloud or enterprise use case. And for telecom, we also have our design contributions into OCP telco, such as open OLT design, such as open cell site router design, and our open router design. So we are working with our customers and partners through this product contribution, and we start to work on real testing, evaluation, POC, and deployments. And the third segment is the enterprise and the campus. So we also have the open 1 gig switch, PoE switch design contributions together with open Wi-Fi. These two could combine as an open campus design. And we will have a very good example on this later. And on top of these open hardware contributions, there are many potential good startups see the market gap of they need a very viable and visible networking operating system. So from 10 years ago, we worked with Big Switch, Cumulus, PK8, IP Fusion, these very innovative NAS vendors. And we started to provide a bundled solution to our customers and the partners. And through this year's development, there are start to have 3 segments. The first is the data center segment. So we have our open hardware contribution, and on top of this, there is a segment for this data center, and there are many different NAS partner ecosystem built on top of this. And because of the emerging 5G era, so there are more and more software startups and the partners focusing on the telco part. So on top of our open hardware design contributions, we build the networking operating system partners for telco here. And the Third, the software ecosystem partner is for the enterprise part. So as we can see here, there are total 3 different segments. And on top of our open hardware design contributions, we support, we collaborate, and we contribute to make this ecosystem growing bigger and bigger. And for the commercial part, in addition to the commercial software offering, we also contribute on the most important open source software. So for example, we contribute on Open Networking Linux, ONL, already many year project. And we participate in Stratum from ONF. We participate in ONOS controller from ONF. And the recent very hot topic is the Sonic from Microsoft contribution, and also the AT&T DONOS in Linux Foundation. So we also participate in this open source software ecosystem and contribute our part to make sure our partner and customer, they can work with us to explore these innovative technologies. So understand the idea of the open networking and why we need open networking. And on top of these hardware designs, we build the software ecosystem together with the communities. From this page and the next few slides, I would like to share the field experience in the past few years, how we work with our partner and customer, how to adapt this open technology into their daily use environment, in their production environment. So the open networking here comes from the hyperscalers want to have effective scale out architecture for their data center. So this leaf spine architecture is already a field proven architecture that also many OEM like Cisco, Arista, Juniper also promote this architecture. And here we have a very good many proven breakers in different markets that our partner Cumulus, they are very leading in these solutions. And based on top of this open hardware design and with Cumulus, we can build a very large scale data center with a very good enjoy the cost reduction and efficiency. And because of the needs of automation and different, the automation among different vendors. So there are emerging technologies like network orchestrator, full life cycle automation orchestrator. We will have Netris later, and we will also have Abstract as a solution partner here. So this part is emerging and proven, and still there are many good details of this use case deployments. So we already start to see even enterprise, even banking already done some deployments using this architecture. And we also see the Sonic start to deploy, start to support these technologies, and that provides our customer and partner a different choice, which is an entire open source choice. So here I would like to give you another example. Some customer ask us, my scale is not like a hyperscaler, not like those very large tier 2, but I also would like to try out this open networking technology and solutions. How should I have a good start? So this case is a very good case, how we guide our customer and the partner. We start from small, okay? This is only just a 5 rack, 10 rack. It's okay. And it's there too, spine and leg design and really fit their existing infra design. So there are 2 zones. One is DMZ zone, another is intra zone. So in this case, we help our end customer redesign and rebuild their legacy data center infra into modern open networking infra. And in this case, we are using Ansible to help our customer to automate this design. And already several of our small scale customers already adopt this design. And this design is already working very reliable and very stable. So they are happy. They already, from this small scale investment, they start to learn, oh, this is open networking technology. It's not like so seeing scary and afraid. I can start from small and then to plan a larger scale. So this is a very good case sharing about how to use the stable design, and let's start from small. Sorry. And this is a more advanced solutions that also very we received many inquiries about this design. In OCP telco, we contributed an open OLT design here, which is a red circle. And we work with ONF to have the SEBA, which is software-enabled broadband access solutions. So ONF provided the software stack, open source software stack, and we use the open OLT and OCP hardware here. And our total solution partner here are Redis, Sterling, and Nesha. And we work together to innovate this access network technology. So by these solutions, ONU and OLT start to unbundle. This really give our telco customer more choice, more options. They don't need to bundle the ONU OLT binding together anymore. And they can run the open source software stack on the server, and that part can keep evolving. They just use the SDN control to control the underlay hardware. So we are helping our many telco customers to adopt, to do field trial on this SEBA technology right now. And we help them how to design their next generation access network by using this technology. And another example is the 5G mobile backhaul network using the open cell site router. We contributed the cell site router design into OCP telco, and we work with our software partner, IP Fusion, Adva, Infinera here to provide mobile backhaul networking solutions for this. So when we discuss with our telco customer, they ask, hey, how should we deploy your solution? And this diagram exactly explains how we help our telco customer to deploy this open technology and solution with existing infra, because our telco customer, they have existing 4G deployments. And how we deploy this? So there are two options. One is to introduce the open CLI router in sub-access ring, newly add sub-access ring. Another one is to increase the bandwidth using this open CLI router in existing access ring. So we work with our telco customer and decide which option they want to take, and carefully try out this technology and solution, and start to plan the production. And we already see many good deployment records on these solutions. And the last example is the previous one about the campus. So in this case, our customer use the open source SDN controller, and they adopt the open flow technologies. And Edgecore here, we help them. Okay, we have open hardware that support open flow. We have open Wi-Fi that can under your SDN controller control, and the entire solutions is governed by this SDN controller. And because of the flow-based programming, the beauty of it, so we can have better isolation, we can have better visibility of this technology. So this is a good example how we have deployment records of the campus and enterprise access market. So previous, we just shared about the real experience on how we help our customer enjoy and deploy this technology and solutions. And in recent years, Sonic become a very, very important networking industry change. So let's see. Sonic is contributed by Microsoft, and it means the software for open networking in the cloud. The reason why we see its potential, because Sonic, the network operating system in open source, in native, it's a container-based design. So the container-based design, which is very ideal for many cloud native deployment, cloud native design. So our customers start to enjoy, start to try out, how should I use this Sonic technology in my deployments to help about my total cloud native solutions, and I can deliver the cloud native applications to meet my business demands. So this is a very innovative technology, and we are working with our customer and partners to explore more how to adopt Sonic in each different use case and scenarios. And this Sonic in OCP really plays a very important role. So we can see here, there are ONI level. So it's a base OS installer. Sonic can install via this ONI, and we also, Sonic can work on this OCP approved hardware. And the most important part is the site driver inside this Sonic. This site driver brings different ASIC vendors together in this community, in this ecosystem, which is very important. So for this Sonic, Edgecore also contribute and commit to provide these Sonic options on top of our open hardware design. So we can see from ranging from 10 gig, 25 gig, 100 gig to 400 gig. And we are still working on making Sonic available on our 1 gig design to meet our customer queries and questions. So Sonic really is a important. Sonic really makes this open networking more choice and more rich and more innovative. So this is about the open networking that Edgecore offers. If you would like to try out open networking, right now there are many offerings. For example, for the lab rack here, by this rack, we can try out the PON technology. We can try out the mobile technology here. So we call it Lab as a Service, Edgecore Global Lab as a Service here.
Great, thank you, Powen. Victor, would you like to summarize a bit about what some of the key points that Powen mentioned?
Yes, Steve. Thank you. I will have a couple words for our attendees. Итак, то есть подведем небольшой итог, о чем речь. То есть я уверен, что многие поняли, но если возникают вопросы, напоминаю, можете написать прямо в чат и задать их в реальном времени. Итак, Open Networking в целом идея дезагрегации аппаратного обеспечения ИПО, а также открытого доступа к дизайну аппаратной части и программного обеспечения. Доступны как варианты, то есть когда вы покупаете железо и ставите полностью open-source программное обеспечение, полностью бесплатное. Это могут быть как сырые исходники, которые вы можете подготовить сами, но, как правило, все большие проекты открытые, они готовят готовые сборки, которые устанавливаются при помощи стандартного для индустрии инсталлера ONI. Вы можете использовать это как в дата-центрах, в операторском сегменте, в обычных кампусных сетях. То есть это решение не каких-то специфических задач, то есть есть, конечно, решения для отдельных специфических задач, но в целом разработки ведутся для решения сетевых задач в целом. Это также может быть стандартный коммутатор, на который ставится бесплатное ПО по аналогии с обычными вендорами. Это может быть ПО, управляемое выделенным SDN-контроллером, решающее различные задачи. Если вы желаете подобное протестировать, да, есть готовые лаборатории под специальные задачи, допустим, для того, чтобы протестировать открытые OLT, то есть для PON, GPON, GPON сетей. Есть возможность протестировать операторские роутеры, коммутаторы для дата-центров. И, то есть есть решение от 1 гигабита до 400, и это продолжает развиваться. Вот. Если есть желание протестировать, это можно начинать делать как с одного коммутатора, можно несколько стоек построить или сразу замахиваться на огромный дата-центр. Возможность есть, то есть эти коммутаторы достать не так сложно. Тут, если что, поможем мы или другие партнеры и подскажем, какое программное обеспечение стоит использовать в том или ином случае. О том, как Open Networking помогает не просто закрывать текущие задачи, но и в целом развивать решения собственные по управлению, как оптимизировать задачи эксплуатации сети. Сейчас расскажет наш друг Алекс Сараян из компании Netris. Alex, please have a word.
Hi guys, hi Victor. Всем привет. I'm glad to see you here, guys. It's a great opportunity for me to be here and speak for you together with Steve and Powen and Victor. First of all, a couple of words about myself and our young company. So I'm Alex Sarian. I'm CEO and product manager and co-founder of Netris. My background is like most of you, I've been network engineer for like 2 decades. So are my co-founders. I'm glad that focus of this webinar is open networking and OCP, because for me, open networking and open compute project is first of all an opportunity. When I was just an engineer back then, for me, I first heard about OCP maybe like 4 years ago, and I was very excited with the opportunity, with the technology, and the idea that, oh wow, I can take this switch and I write a code, put that code into the switch, and that switch will do whatever I want to do. That only idea was super exciting for me. And for me, this has grown into larger opportunity to found this company, Netris, 3 years ago. Back then it was called Edgecore Networks. And recently we have renamed into Netris. So Netris is found by engineers primarily. Our business office is based in Silicon Valley, California. So myself and people moving like product marketing and sales are based in Silicon Valley, California, and we have our development office, research and development and support office based in Yerevan, Armenia, not much far from your location. Silicon Valley is a great place where you can find a real talented people with huge experience, and so are our strategic advisors, and we're very lucky to have these advisors. Mike Dworkin, he's pretty much father of Cisco ACI. By the way, Mike Dworkin lived in Moscow before before immigrating to the United States, and Carly Stoughton she's helping us on the marketing side. You probably saw Carly on one of these Cisco ACI videos. So great to be in Silicon Valley because you have access to such people, which are incredibly important for moving company forward. And a little bit about the inspiration and the big idea. So we all saw public cloud, right? And public cloud is exciting. And the main reason why public cloud is so exciting is because, in public cloud, everything is so easy, because oftentimes our goal is not to configure particular protocol in particular way, but our goal is really to make infrastructure to run some applications, and our goal from the network is to make network to move bits between applications. And public cloud is exciting primarily because it's so easy to operate. You just deploy your application, you apply some bunch of policies, and public cloud just works. And we were excited with this idea when we were starting this company, because my idea was like, hey, we're spending so much time on operating networks, but in cloud, all that time is not wasted. But why don't we bring that cloud principles into physical networks? And looking to the industry in general, what's happening, we see that most of the companies are considering heavily private and hybrid type of infrastructures. So public portion of this is pretty straightforward, but what is private or hybrid cloud? It means that companies, oftentimes what we see, they are considering operating their physical private infrastructures like a cloud. And what we say, what we understand when we say like a cloud, we mean cloud experience. When things are automated, when you just deploy software, you just apply policies, not particular commands, and it works. So main reasons for this debate, like public cloud or private cloud, the main reasons for considering private cloud are cost, because public cloud is expensive, especially when it goes to the scale, right? It's very good in the beginning, but when your business is growing, you may consider, turning a hybrid infrastructure. So cost is a big factor there. Unpredictability of budget, because oftentimes, we all heard about these unpredictable bills on public cloud. And for some businesses, you want to process data closer to the source of the data or your customer. Sometimes it's a matter of lock-in or some business reasons, right? Some businesses, they cannot run in the public cloud. They have to have a private infrastructure. But that doesn't mean that when you're running a private infrastructure, it doesn't mean that you cannot operate your private infrastructure as easy and as comfortable as public cloud. And in fact, the tools that are used in public cloud are actually available for private infrastructures as well. Let's take, Kubernetes, which is becoming super popular these days. Like, Kubernetes is designed in such a way that actually there is no difference whether you run Kubernetes in public cloud or on private cloud. So, okay, I want to make my private infrastructure super efficient. I'm using Kubernetes in public cloud, and I want to do the same in private infrastructure. That sounds pretty doable. But the major problem is that network has a user experience problem. I mean, traditional network. And for anyone who is used to public cloud, running a physical network would be shockingly hard. And in fact, most of the failures on the network side are happening because of misconfiguration, because of propagating of misconfiguration. Even when you're using traditional orchestration or scripting type of approach, it's a template, and if there is a mistake in a template, that mistake will be propagated and will break the network. That's human nature, and that's fine. We humans are not as good as software on doing that, specific things. Humans are great on doing creative things, and open networking is a way to apply that human creative approach to everything in networks in particular. So let's look into open networking. What is it and why we were so excited 4 years ago when I first saw open networking? So at first look, open networking is, first of all, for me, it's a switch ASIC, which is moving packets at the speed of almost light, and there's a Linux. So it's a switch with a Linux. I understand Linux. I can put a script, I can write in multiple languages, I can push that into that Linux environment, I can leverage, standard Linux tools, put something together, and it just works. Like, imagine doing this kind of thing with Cisco or Juniper. I mean, come on, that would be super hard. In Linux, it's just minutes. Let's look deeper into this. So, open networking switch, I separate it into some layers, right? We have a physical layer where we have ports. So there are, bunch of different flavors. Like, you can have 48 times 25 or 10 gig ports. You can have from 6 to 8 100 gig upstreams. You can have 32 times 100 to 400 gig ports. And for these white box switches, when I say 100 gig port or even 25 gig port, oftentimes we can break these ports into smaller ports. Like, your 100 gig port can be converted into 2 times 50 gig ports, or 4 times 25 gig ports, and or each of these 25 gig ports can work either 10 gig speed or 1 gig speed. So there's a lot of flexibility. So that's port layer. There's layer of silicon. So one thing that is making this, disaggregated open networking happen is merchant silicon. like compared with the traditional silicon, traditional silicons are closed. There's no much flexibility. But the merchant silicon means that one company, for example, Broadcom, is creating these silicons and selling to every company wants to buy. Like, for example, to our wonderful partner Edgecore. So now Edgecore has this great opportunity to create that open networking switch and sell to customers. So customers have this flexibility to install whatever operating system there and do fantastic things. There's another critical layer, the abstraction layer. So you need somehow your system, your operating system somehow needs to be able to configure that data plane of the silicon. How that happens, there are multiple ways for this. I'm covering some very popular. So one way is through Linux kernel. There is this wonderful driver, switchdev. It's a part of Linux kernel. What it does, it looks into kernel routing table, it generates appropriate microcode and pushes into ASIC. So basically, when you configure something in your Linux environment, switchdev will pick that up and will push into ASIC. There are others. Tsai is another, maybe the most flexible type of abstraction layer. So Tsai is wonderful because it even disaggregates things more. So someone who is creating the operating system just includes Tsai, and someone who has created the ASIC just provides necessary specifications and developments into Tsai driver. And operating system vendor just plugs that things together, and it just works. It's probably the easiest way for integrating this merchant silicon with the operating system. There are also commercial options, like Cumulus has its own switch D. How it works, it's a commercial, like a blob. So Cumulus is partnering with the merchant silicons. They work together. They do some coding, and the code does pretty much the same. Reads the kernel and puts the microcode into merchant silicon. Going layer up, there's operating system, and there are multiple flavors of operating system. Sonic is recently very popular. Cumulus is the commercial one of the pioneers and pretty stable network operating system. They were recently acquired by NVIDIA, no surprisingly. Sonic is free operating system, just like think like Ubuntu, for example. Dent is coming up soon. It's another free operating system by Linux Foundation. And also you can, oftentimes you can use just a Linux you like. And we do that. We like oftentimes use just Ubuntu with some drivers compiled. We pretty much put together our flavor of Ubuntu. And on top of that operating system, you run applications in user space. Like FRA routing is an example of routing daemon. So you want your your BGP, your OSPF, all kind of control plane stuff. FRA is doing this. It is pushing stuff into kernel, into routing table of the kernel, and then abstraction layer drivers push that all the way into ASIC, and then your switch understands how exactly to move packets. So that was kind of high level dive into what's happening inside the open networking switch. And now logical questions, which I had before, and probably you had these questions. So that switch is cool. How do I configure it? Well, it's a great question, and there are multiple ways to do that. First of all, before configuring, you need to find out your best mix of the things on previous slide. The best hardware configuration, primarily in terms of port configuration, like for any whatever crazy port configuration you need, Edgecore as well as other vendors will provide, because with this open technologies, it's much easier for hardware vendor to provide with all kind of flexible options in terms of physical ports. And you also can break ports, as I've explained. You can take a switch with a, like we worked with customers who are taking switch with 100 gig ports into a rack with the servers, and they break 100 gig ports into 4 × 25, and they plug just one cable on switch side, and they end up with 4 cables on the other end. So they connect 4 servers utilizing just one port on switch side. So there's plenty of options. You find your best options in terms of port configuration, operating system, which works best for you, feature set, your applications you run on top of operating system, you make your mix, and then you can start configuring. So the first and most obvious, the simplest way to configure is using CLI, and configuration files. For those who are familiar with Linux, it's Linux. You configure it like interface SD file, you configure FRR. It's very super similar like in traditional Linux, but you should understand that you are configuring network device. The interface is Linux, but it works like network device. Whatever you configure there, you should always keep in mind that actual packet forwarding is done by the switching silicon, not by the kernel. That's the major difference. For those who are familiar with like Cisco interface and unfamiliar with Linux, I would say from configuration perspective, ideas pretty much similar, like fundamentals are the same. You just have different set of commands to configure these type of switches. And I know it's a temptation to to automate things, to develop scripts, to apply Ansible and all kind of infrastructure as a code, these type of things. It's there. It's Linux. Like you probably saw how DevOps people are automating deployment and operation of their Linux machines. You can do similar stuff here. That will take a lot of time. True, but it's possible. You have the environment. So one thing is configuration, but networks needs to be monitored and troubleshooted. And again, since this is Linux, there's bunch of open source and commercial tools. You can pick whatever works best for you. And your probably favorite Grafana or Prometheus or ELK stack, all these things are there. From perspective of these tools, it's just Linux. You just integrate these things in a standard way. You put together a solution, a very custom solution, and that custom solution works for you. Now, how about DevOps, the application platform? How about this cloud experience that I've mentioned in the beginning? So open networking and OCP is a wonderful opportunity for anyone. For me, this was a fantastic opportunity to start a great company funded by a venture capital, to put together a fantastic team. And every day when I wake up, I do the most interesting job in my entire life. For me, open networking was this opportunity. And it's it's a universal thing. It provides different opportunities for different people. Like for hyperscalers, open networking is opportunity to create their custom homemade solutions, which is good for their hyperscale. When we speak about cloud and cloud environment, like the public cloud is also running on this open networking infrastructure. But like one guy said, you will need a lot of glue because there are many moving parts. There are hundreds, maybe thousands of components that you need to glue together, and you need to follow up with the new releases of all these various components, make sure you maintain your code. That's all doable. And for every company, you need different approach. As I said, for hyperscalers, that's probably the best solution. For enterprise companies, sometimes it makes sense to do the glue thing in-house. That takes a lot of time, a lot of money, and a lot of passion. For other companies, especially enterprise segment, it's better to take a ready-to-use solution which has already put a lot of glue there, and it's proven, it just works, and just benefit from that cloud experience and benefit from using APIs and so on. So Netris is such a solution. So we say that Netris is an automatic network operation software that operates your physical network, providing you with a cloud user experience. So what does that mean? First of all, that means that we help our customers to get a great separation of concerns. Like different roles on the company can cooperate better together. Like I know these two camps of network engineers and DevOps people. This is like a historical place of tension, if you will. So DevOps engineers and NetOps engineers always had this fundamental thing that, I was a network engineer and I was looking to this from a network engineer perspective. I'm sitting in front of my computer and all the other departments are approaching me like, hey Alex, we need this new VLAN here. We need to upgrade that link there. The mlog is not good or something. Bunch of requests. And in fact, the way we implement this request, we network engineers, we provide some service to our colleagues that are using network, because network is a service for applications to run, right? And we network engineers, our goal and the main goal is to provide this great service to our colleagues so they can run applications. And the Netris was created with this idea in mind, where network engineers, they apply a set of policies to run the network. Network engineers tell the system how your leaf-spine fabric should behave, how your upstream connections, how your BGP sessions to your internet providers should behave through policies. You don't really need to deep dive into configuration if you don't want. You just define policies, and Netris has this built-in policy engine which takes your policy and automatically figures out what exact configuration needs to be done. So Netris has this ability to create this machine-generated configurations which are never wrong. There are no mistakes, there are no typos in machine-generated config. It's good for everyone. NetOps engineers are spending less time on doing these repetitive things, and also network engineers have this opportunity to delegate some pieces of network in a safe way to DevOps people or others, so they can use this like a cloud. And the beauty of this solution is that everything underneath is based on open networking technologies. You can use these OCP switches. You install one of the open networking operating systems. Whatever Netris configures is 100% based on standards, you always can see what is there, the configuration, and so on. And you can easily integrate this with your favorite Kubernetes or Terraform or VMware, and these things will work just natively. So that's just high level what Netris is. In fact, with this better and automated approach, no matter if you use Netris or you build in-house, you can get to these numbers. 80% of cost saving on operational side, 90% of saving on time. Ops are spending on details, unnecessarily details, and get the uptime of 5 nines, because there's no human factor when you do things in an automatic way. There are many of use cases. I want to pay your attention on some of this. So cloud repatriation is a big and good use case here, which means, like, imagine company, maybe it's someone of you are working in such a company. So imagine company starts in public cloud when they are small. That's probably the best and most optimal solution for them to go. And company grows, and so does their cloud bill. And one day they want to, they decided that they reached the right size for start, building their private and hybrid infrastructures. And because you started in public cloud, you would appreciate to have the same, simple and easy operation, approach for your private infrastructure. And that's, what open networking and programmability allows you to do. Edge processing is another vertical which is recently growing really strong. So all kinds of distributed edge cloud providers or training of machine learning models. This thing required to be either close to customer or closer to source of the data. So that would require highly distributed networks or local networks. And again, automatic approach can be really very useful here, because this automatic cloud style approach allows companies to focus more on their core business and spend less time on on detailed things which are not critical for their business. Local Kubernetes is a big use case. That's why we're so bullish on integration with Kubernetes. So there's a big case when you run Kubernetes locally. Your Kubernetes is designed for cloud environments, and there are some things that Kubernetes would expect cloud network environment to do, like load balancers are a good example here. Like when you deploy application with Kubernetes, one of the ways, and probably the most common ways of exposing your application's port to public internet is to use what Kubernetes calls type load balancer. And it's a service which Kubernetes is expecting network environment to provide. With open networking, you can either put together some in-house development that will talk to Kubernetes API, understand what Kubernetes API requires right now, and you provision that. Or if you are using Netris, you just click create new Kubernetes cluster network, and you're done. We will automatically sense that what you just requested is a load balancer, and we will provision that automatically in less than 1 minute. Everything will work underneath on open networking technologies. So there are many use cases. Like small ISPs are having success with these technologies with us. Application provider companies, like all kind of entertainment providers, advertisement providers, anything online are having success with these technologies. All kinds of distributed, like edge cloud providers, these kind of companies. And because this is for this region, I'm very pleased to share this information that we were extremely lucky to have this great company headquartered in Moscow called Innova to become our customer. Some of you probably heard of Innova. So they are leading online gaming company, official publisher of these famous games like Lineage or Point Blank and many other household names. But what is most exciting for me with Innova is Innova's team, because when I worked with them, I've noticed that the level of expertise is so extremely high. Like working with Innova, you learn a lot. And I'm glad that we had this opportunity to work together, because our company learned a lot from this team. And I'm also happy that Innova also benefited from our product and open networking technologies. And we did this with Edgecore Networks, maybe one of the early adopters of Edgecore and OCP technologies in this region. So thanks everyone. Let's keep in touch. I'm on I'm LinkedIn, Twitter, Facebook. I'm Alex Saroyan. These are my email address is also here. Guys, I'm happy to be in touch. Like any question regarding open networking, please feel free to reach out. Not even related to NetRes, not necessarily, just any question. Hey, Alex, recommend, what's your take on this or that? I'm happy to take that questions. I'm happy to be helpful. I'm happy to talk with you and exchange ideas with you. So thanks everyone, guys. I'm glad to be here, and I'm looking forward for a Q&A session that we may probably have here.
Great. Alex, thank you very much. And for those of you in the audience who think that Alex may not be serious when he says reach out to him, that is completely false. He is extremely open, and he is one of the more engaging community members that we have. And I highly recommend that when you look at open networking, it's having a solution provider like Alex and the team at NetRes that really understands this and partners well with people like Edgecore to be that glue that you need. So thanks again, Alex. All right.
Thank you.
So moving on, this is just really additional links which we will be sending out and posting this presentation along with the recording after the session. So please use these links for additional information about Open Compute. And for those specific products that Powen has mentioned, or the software that's riding on top of that, you can go to our marketplace at opencompute.org under products and integrated solutions as well. So now, Victor, I will turn it over to you to summarize, and perhaps we can start to see if there's any questions.
Yep, sure. Итак, коллеги, если у вас есть вопросы, можете прямо сейчас задавать их в чат, или же вы можете написать вопросы в отдельную секцию. Как мы видим, был один вопрос. Продублирую для тех, кто, может, не говорит по-русски. Guys, you're free to ask any questions in chat, or you can send your questions in specific box in GoToWebinar platform. So anything about open networking, about hardware platforms, software, how could you use that or different stuff? And so let me open up a bit a question about front haul router boxes. So as already answered, yeah, at least Edgecore has several hardware designs for 5G networks and etc. which are already integrated with software from IP Infusion, Adva, and Infinera. It could be used just as a cell site router for transport and so on. Also, there are a lot of different solutions. So you can even use Open Run software with different hardware. So if you're looking to make open not just your data center or something else, but also mobile network, you're free to go. We can discuss it.
Victor, there's another question here. Which kinds of companies are possible for open networking in Russia?
Actually, I will say in Russian. Let me speak in English first of all, because the question is in English. It could be any company in Russia. If you're speaking as a company which is a consumer, so anybody could be a consumer of open networking products. First of all, it's not about specific integrations. Yeah, of course, we have different kinds of software to work in data center, in telco, in enterprise, for example, retails. But you also can find software for your specific task. If you can't choose which you better to work with, you can ask help me, Alex, Edgecore guys. So here in presentation, you can find all the contacts, my email of Alex. We can help you to choose free software or commercial software. Rather, you need high quality support for specific case, or you want to make your own specific solution. So it's all up to you. And a bit in Russian. То есть вы можете выбрать коммутатор и любое совместимое с ним программное обеспечение использовать в любых сценариях. Естественно, нужно опираться на то, какие задачи может решать то или иное ПО, так как, естественно, любой образ, любой дистрибутив не может реализовать все, что вы желаете из коробки. Где-то придется что-то доработать, пообщаться, может быть, с разработчиком. Если вам действительно интересно попробовать новый подход, когда вы можете сами влиять на свою инфраструктуру, менять программное обеспечение, или использовать одно конкретное программное обеспечение, одну операционную систему с различными аппаратными платформами, будь то Edgecore и другие производители, неважно. Да, вы можете использовать что-либо из доступного. Если есть сомнения, вы можете обратиться к нам, то есть ко мне, например, в почту написать. Вы можете написать Алексу Сараяну, он с удовольствием поделится своими соображениями. И также коллегам из Edgecore, Стиву из OCP. То есть мы поможем подобрать то, что нужно. Это в первую очередь не про коммерцию, это в первую очередь про сообщество и про развитие открытых технологий вообще по всему миру, то есть не только в России.
Great. I have a question for Alex. So Alex, if you're a company out there and you don't know how many team members you need to start on open networking, and what if I already have a group of people that know a traditional set of hardware tools? What do you recommend for people that aren't skilled on Linux and maybe have a small team? How would you advise, and how many people do you think it takes to get going on this?
That's a great question, Steve. So most of our customers, I would say even all our customers, they were in the situation that you have described. They had these traditional skills. They were willing to adopt this, cloud technologies. They understood that open networking is sort of a key to getting to that cloud technologies, but building things in-house didn't make sense for them. I mean, that's definitely an option. That's doable, but that depends on the scale of the company. And as I said, if you're hyperscaler, of course you have to build this in-house. But if you're a smaller company and you just want to make things efficient, then NetRIS may be a great choice, because the traditional knowledge is good enough to start pretty fast with NetRes. Like you need just several hours to get the main concept, and we always, in the beginning, we always help new customers by training them, by attaching a network engineer to new customers, so he will make sure that transition is smooth, and we'll be there to answer the questions. And you get learning with every day using NetRes and this open networking technologies. You learn every day. You slowly and smoothly transition to this cloud type user experience. You make your company more efficient. You make your colleagues more efficient, because your colleagues can consume network services easier and faster. So it's win-win-win for everyone. Your company gets better, your colleagues get better, you get better, and you don't really need to spend a lot of time on learning. You don't need to hire a lot of people. That's really easy, and I'm always open and happy to show this around. And actually, I forgot to mention that we have sandboxes that we give away for free, that people can get a sandbox, play around, and try some features just without need of any deployment. It's a virtual cloud environments for feeling the product and open networking technologies.
Yeah, I was going to mention that. So if you go to NetRes's website, you can request a sandbox, which allows you to try, as Alex mentioned, his solution. Also, Powen had mentioned those mobile labs. So we have mobile networking labs that we can ship to your facility, so you can try to get hands-on open networking experience with the gear or with the hardware at your facility. I think, Victor, I think that's it for the questions. Anything else that you would like to summarize? And then if not, we will start to close down.
Yeah, sure. If there are no questions, we can make a little summary here and just finish it. Итак, коллеги, большое спасибо всем за внимание. Мы обязательно отправим вам запись и презентацию. Как Стив говорил, мы разошлем ссылки на материалы, чтобы вы могли дополнительно ознакомиться в дальнейшем. Также вы можете задавать вопросы нам непосредственно в почту. И если у вас есть интерес к реализации каких-то специфических проектов с использованием новых принципов Open Networking, когда вы можете не просто использовать какой-то маленький набор инструментов, предоставляемый традиционным вендором, но полностью работать с коммутатором, как с Linux-сервером, использовать свой собственный control plane, вносить изменения в существующий или просто добавлять небольшие элементы, как, грубо говоря, даже Zabbix, агент, что-то еще. Если у вас возникают вопросы на эту тему, также смело обращайтесь, мы подскажем, что можно использовать. Оборудование для тестирования можно получить как у нас в NAG при необходимости, так и непосредственно пообщаться с коллегами из Edgecore. Steve, please, let's finish and show the last slides, I think.
All right. I think that's it. Thank you very much. We really appreciate everyone attending.
And I heard there are a few more questions. So for the last slide, I'm duplicated my contact. If you would like to discuss any of the topics, you can reach Alex, you can reach me. It could be not just email, it could be Telegram, WhatsApp, whatever you like. So we're free to discuss. And
so
Steve,
Victor, that one last question here. This question comes in and asks, well, I understand about the community and openness, but I'm afraid that Russian CIOs will not risk their career and prefer old school proprietary solutions. How can we assure them that open networking is enterprise, is a kind of enterprise class solution? So I will turn it over to Alex and Powen to kind of talk, and Victor, what would you tell an enterprise CIO about open networking?
I got it. So first of all, I would figure out what is the task here. So what tasks our engineers have, and how could we help them? So first of all, we need to pick software. It's not just about free software, open source software, where you don't have any support from developer. But you also have opportunity to choose commercial software, which is not just another one open source software with PT support. No, it's big commercial projects like Arista, Cisco, and Juniper, who have specific tools to manage your infrastructure. For example, it could be Cumulus Linux, which is proven data center and enterprise campus solution for networks. You can manage your network through traditional tools like CLI. You can use automation via Ansible or whatever you like. You can troubleshoot all your network via proprietary NetQ system. For example, if you need specific solutions for network visibility, you can use CGS Tower Networks, who is a young company who already has a strong software base because they have a lot of good engineers, and it's already proven in banks, enterprises, and other companies like telco companies. So they can provide better visibility for your network and kind of functionality of network packet broker. You can use Netris, which is already a proven solution, who can provide you easier management of your network, which provides it not just network with command line interface, but you have like a network as a service and much more solutions. So let's not start from what do we need to use. Let's start our dialogue from what task do we need to solve, what problems we have right now, and how could we benefit from open networking here. As I reminded, it's not just commercial questions. It's questions about how to work efficiently. So we need to ask correct questions.
Victor, can I also answer to this question as well? Yeah. So Denise, that's a great question, and in fact, I really like that question because we're facing this like every day, right? So there are a couple of things, whether solution works and what do we do if we experience troubles if we commit to deploy this solution in production. So how do I make sure that this solution is stable and it works? That's obviously proof of concept, and it's definitely doable. And typically, how we work with the customer is we work with engineers of customer. We architect a proof of concept, and Edgecore usually provides some hardware through partners like NAG. So you can take this hardware and run a proof of concept on your real traffic, and with not to risk your entire traffic, but to risk a fraction of your traffic, a few percents, reroute that part of traffic to your proof of concept deployment and run it for a month or so and make sure that the solution is really stable. And that's very, very fair question. And if I was on the side of the CIO, I would definitely do that, of course, and I would definitely have the question. And when it comes to the bigger question, what do I do if there is a problem? Like I know what to do with Cisco, but what do I do if there is a problem with this open networking? Wonderful story. So first, in case of Netris, we provide this enterprise support. Netris is a subscription-based software. You pay as a subscription, and you get entire enterprise grade support with SLAs, and it's a special type of a support. We are not responsible only for our piece of product, but we are responsible for entire system. Because look, in this open networking, everything is disaggregated. If somewhere is a problem, it would be very, very hard for a customer to quickly, narrow down to root cause. And we at Netris, we understand this because our background is we all worked in these enterprises and we understand this problem. So our take on support is this: if Netris is network operations software, then we should not only be responsible for our software, but if we let our customer to define a service in our software, in our web interface, or using our API, we are responsible for the software, for this service to work all over the way, down the stack. And even if there is a problem with your open source operating system, we got it. We will fix it. We will fix the source code. We will work with, if it's a commercial operating system, like if it's a Cumulus and there is a bug in Cumulus, for example, then our engineers will work with Cumulus to fix that. While we will provide you a temporary solution to save your business, we will work with Cumulus to fix that further. If there is a hardware problem, that happens, right? There is no hardware in the world that never breaks. Hardware breaks very, very rare, but that may happen. Even so, we will do, Netris does a lot of troubleshooting automatically, but besides that, you have a phone number. You just call Netris, you say like, hey, this is customer, this, I have this problem, I don't care, and we got it. That's our take, and I think that should be, compelling answer for the mentioned CIO roles.
Great,
So,
thank you.
okay.
Victor, please summarize, and then we will close this.
Let me give some comments in Russian for the end. Коллеги, небольшое дополнение к последнему вопросу, что не нужно смотреть на Open Networking вот в данных вопросах просто как на новое, ненадежное, непонятное решение, которое нужно саму обслуживать. То есть есть огромное количество экспертов, разработчиков, которые поддерживают, оказывают коммерческую поддержку с строгими SLA. Можно бесплатно относиться. К этому следует относиться как к новому решению. То есть если вы хотите кому-то доказать, что это действительно работает, нужно просто показать, что это работает, показать уже успешные кейсы, если они существуют. И мы можем вам в этом также помочь, подсказать, где найти информацию в конце концов. В завершение еще раз отмечу, что мы открыты для диалога. Можете писать кому угодно из нас. Все почтовые ящики есть в презентации. Если у вас есть вопросы, где достать оборудование, можете обратиться к коллегам из Edgecore, можете написать мне или любому менеджеру из NAG, с которым вы уже работаете, он вам в этом вопросе поможет. So, guys, thanks a lot for attending this webinar. Looking forward to keep contact with you, have new questions, interesting conversations, discussions on open solutions. Thanks. Bye.
Thanks, everyone.